All right, we're starting. On the left side here, you see the rows. There are 3. 1, 2, 3. On the top, these are called columns. Duh. Okay. Rows go left to right. Columns go up and down. You use columns to build things in architecture. So this particular one is 3 rows by 2 columns. So we always do, you can see, we always do the rows first. We'll say rows, and then there'll be usually a X, like a multiplication sign, by the columns. Okay. Today we are adding, subtracting, and then doing scalar multiplication. So you can look here at the bottom of the page. It says find the dimensions of each matrix. We're only going to do the first one. You can look and see that this first example that we're about to do, number 1, has 1, 2, 3 rows. And it has how many columns? 2. So, and I don't know what's happening today. There we go. We would call this a 3 by 2. This is being really wild. Okay. Can you please take 10 seconds at your table and do 2 and 3? Ready, go. Okay, you can check it. The number 2, you should have 4 by 1. Do you see how this is all in one column? This is called a column matrix. When it's all one column, the other ones aren't special. The 2 by 4, 2 rows, 4 columns. Okay, you can flip it. Great, we're doing it. Okay, a column matrix. You only have one column like the one you just saw. So it'd be something like this. And it's brackets, by the way. Make sure you're not doing parentheses. That does matter. So A, B, C like that. If it was all in one row, we would call it a row matrix. And then the other type that we have is a square matrix. It'd be when it looks like a square. So, for example, A, B, C, D. You also have not just 2 by 2, so it could be a 2 by 2, a 3 by 3, 4 by 4. I hope that makes sense. Dot, dot, dot. All of those are examples of square matrices. If and only if they have the same dimensions, then you can say that they are equal. Equal, have the same dimensions, which means they have to have the exact same rows, exact same columns. And then you can set all of their corresponding elements equal to each other. I am going to do 2 of these variables in the next problem, and then you're going to do all the rest. So if you could, and then it's doing the craziest thing. Okay, here we go. So let's find the missing value. So this is where we'll start to use colors a little bit. You can see that this is a 3 by 2 and a 3 by 2. So they have the exact same dimensions, which is why this is going to work. That's not a plus sign, sorry. It's supposed to be a by. Since they have the same dimensions, I can set this stuff equal. So 7 is equal to a plus 3. They're both in that top left spot. You literally just set them equal. 7 equals a plus 3. And then I would subtract 3 and solve this baby equation. What's a? 4. That's it. That's all you have to do. I'll do it one more time, and then I'm going to stop talking, and you're going to do it because it's just so easy. Z plus 3 is in the top right. So is negative 15. So they're equal. That's it. So you get, subtract 3, negative 18. Wonderful. Okay, you're going to try the next 6. Not 6, sorry, 4. There's 6 total. Do the next 4. Solve for B, C, X, Y, and then check it with the screen. Go. All right, hopefully you've tried it yourself. You can check those. I hear some pens moving, so I'll wait a second until I move on. The next one's super similar. We'll do the first step together in just a moment. Yeah, so this is going to work out because you have 2 by 3 equal to a 2 by 3. We'll talk about what to do with that 3 in front, obviously. What's it look like? What's that look like to you? With the 3 in front? It just looks like multiplication. That's all it is. It's called scalar multiplication. In the past, you've called this distribution. That's all it really is. So if you want to write the fancy way, we don't call it distribution when it's a matrix. So it's scalar multiplication. Wow, that's a long word. All right, so it's exactly what you would think you would do. Oh my gosh. You would just multiply to all those terms. So we're going to rewrite this 2 by 3 on the left. And you'll notice that I put x plus 1 and y minus 3 in parentheses because you do have to make sure you distribute to both of those terms and those elements. So 3 times 7 is 21. 3 times x plus 1 is 3x plus 3. So I'm going to go ahead and do the distribution now so I don't have to deal with it later. 3 times 5 is 15. 3 times the quantity y minus 3 is 3y minus 9. 3 times z is 3z. And 3 times 4 is 12. By the way, we're going to do a lot of stuff with z over the next couple weeks, so I'd encourage you to start putting slashes through your z's so that you don't get confused with the 2's. Okay? And then at this point, it's the same exact type of problem that you had before, right? 21, 24, 15, and you were just looking to set the stuff that's in the same corresponding spot equal. So you don't have to do every single spot this time, though, because just the variables, right? You can see we got 21, 21. That makes sense. They're equal. So 3x plus 3 equals 24. And then you just solve. So that would be subtract 3, divide by 3. 7. Can you please solve for y and z? Go. All right, after you tried it yourself, can you please check it? Check your x, y, and z, and then I think we're going to flip to, we're going to read the bottom of the page before we move on. Sorry. Okay, you can see it says, the bottom of the page, some stuff about adding and subtracting. So basically the same as when you have equal matrices, you can only add if you have the same dimensions. Sorry, it's on the wrong screen. There it is. Okay. You can only add if they have the same dimensions. So if you could look at the next example, we'll do one together and then you'll do one on your own. Okay, on the next page, you see you have subtraction. So just like you've done with maybe a polynomial in the past, when I see a minus sign in the middle, I'm going to actually do that distribution first, which is not distribution. I guess it's multiplication by -1. Okay, so we're going to scoot down here. So this is on the next page for you. Okay, and let's go ahead and do this multiplication of negative first, just because it's going to help you not make stupid mistakes. Because you can see this math that we're actually doing, not that hard. It's just trying to make sure that you do everything in the right spot and you don't make silly mistakes. So I'm going to switch it over to a plus sign and then just change the signs on everything in this right matrix. These are 3 by 2s and 3 by 2. Since they have the same dimensions, I can subtract them. So do you have to do this way? No, you could do the subtraction in your head. It's fine, but I'm not. So 2, -1, -3, 3. So all of those change signs, and then you're just adding spot to spot. So 2 plus 1. Is 3. And then you would just repeat that with all the other elements. Okay, can you finish this problem, please? Do the other 5 elements. Go. Okay, there's your answer for that first subtraction example. You can check it when you think you've got it. Hopefully I didn't make a stupid mistake. And then go ahead and do the addition. This next one, you don't have to distribute anything because you're literally just adding. This is an example of, this is a 2 by 2. So this is a square matrix for the sake of learning, because you can see it makes a square. Okay, go ahead and add spot to spot, just like you've done before, and then you can check the answers with the screen. There you go. Okay, everything gets multiplied by 4. You should have this. All right, here you go. Sorry. All right, we're going to do, I guess, 2 more little ones together. If you flip to the next page, actually, we're going to come back to these ones with A, B, and C in a little bit. You're going to do them. I'm not really. Okay, and then you'll try these in a moment. So flip to the next page. We have 2 last examples to do. You have some scalar multiplication here in the middle. So this -2 is getting multiplied to that middle matrix. So you would want to go ahead and multiply it out. Do scalar multiplication. Remember that z minus 5 is all one element, so you make sure you distribute to that. I'm going to rewrite this entire equation. So you've got 3, 2, and x. I'm going to rewrite it. No, maybe not. Switch pens. 3, 2, x. And then here we're multiplying by -2, so I'm going to switch that to a plus sign. Since that negative is going to be gone now, it's going to be inside the matrix. -2y. This would become -2 times z minus 5 is -2z plus 10. And then -2 times 10 is -20. Okay, so there's a second matrix, and then I'm going to keep this one on the right the exact same. So all I did was multiply by -2. And as you would expect, at this point, you're just going spot to spot. So looking for the corresponding elements, so I have, we'll do the 3. So 3 minus 2y is equal to 1. And then you write an equation and you solve. I guess it's 3 plus -2y, but I'm going to ignore that. So 3 minus 2y equals 1, and then you would solve that little equation, right? So I'd subtract 3, divide by -2, and y is 1. Can you please finish this up? Solve for z, solve for x. I will color code it on the screen for you, but I think you can probably do it. Okay, when you tried it yourself, can you please check those 3 values? And we're going to talk about this price one, which is kind of a word problem, but in matrix form. And then you'll go back to the previous page and finish those A, B, and C ones. So in the price matrix P, which P is being used to call, like that's the name of the matrix, is P. We can use capital letters to call matrices by name. Rows represent prices for sweatshirts and sweatpants. The columns represent the color scheme of each item, white, red, and tie-dye. So you can see we have prices here in this matrix. If the sales tax rate is 8%, find the sales tax of each item. Okay, 8%. We wouldn't want to multiply them all by 8. What we want to multiply by? 0.08, right? The rate is, we want it as a decimal. 0.08, because you take 8 and divide by 100, or move the decimal 2 to the left. And so you are multiplying all of this by 0.08. I don't really feel like writing it all out again, so I'm just going to do it like this. Okay, so what I'd like you to do is go ahead and multiply that all by 0.08. That would give you the sales tax for every item, and then you're going to put it in a matrix, okay? And then you're going to flip back to the previous page and do the ones that's all about like A, B, and C. I will put the answers for A, B, and C for all of those up on the board so you can check them. And I'll put the answer up for this one as well. Just give me one sec. And you are going to try the 6 questions. It says B plus A minus B, 3 times A, -5 times A, etc. On the previous page, and then try them yourself. That's kind of how you'll know if you actually get what's going on today. And then you can get the homework packet after you are sure that they're right. Thank you.